Hello guys, welcome to Sharper Tutorials. In this session I will be discussing about more trusses subjected to different types of loads and different conditions as well as different supports. So let us begin the session. So first we will be doing the upper one. As you can see, the supports are pinned and roller and height is given, length is given, loads are given. So let us begin the session. Initially start pro. You can see the units are pounds and feet. So select new project, select truss, give some name, select foot. As you can see, 11 feet 0 inches and pounds. Select next, select OK, select add beam, finish. Okay, in our figure we have total 6 bays of 11 feet. So we'll make along x direction 11 feet and 6. So you can see there are total 66 feet. Then 19 feet height can be obtained here. So let us start. So you can go to geometry, run structural wizard, select half a roof. You can see the units are in meters, so it would be difficult for us to have it in structural wizard. So let us do it manually. So this is one bay, second bay, third bay, fourth bay, fifth bay and sixth bay. And then as per our figure, you go 19 feet upside exactly at the center. Escape. Now you can we need here and here, so we'll do one thing. We'll just draw it like this. Then again here. Now you can switch off the grid. As you can see, this is extra part we don't require. So we go to geometry, select intersect members, intersect. Okay, now we can delete those beams. And remove this node. Now you go to geometry, select add beam between point to point. So as per our figure, it is this side, downside. So we select both the nodes. Okay, here is our truss. as shown in the figure. Let us start. So initially go to general property, select define, select assign profile. So the profile specification will be angle, select add, close. Now assign profile specification angle to the entire structure. Going to support, create support. First one is pin support and the next one is fixed butt. I can say roller support, which is fixed butt in Staad Pro, and you need to select FX and MZ. Release at FX and MZ. Now select fixed support and assign it to the node. Now go to loads and definitions, select load case details, select add, let it be load case 1. Coming to nodal loads, as per our figure, one is 8000, then next one is 6000 and 4000. So minus 8000 minus 6000 minus 4000. Negative symbol is because the load is acting in downward direction, as we all know it. So as per our figure, we have 8000 exactly at the center, 6000 here and 4000 here. So select 8000, assign to that node. Similarly 6000 also, then finally 4000. Then you just scale the loads. Now go to design tab, select steel tab, select code, initially IS800, select define parameters, select FYLD. Okay, let it be default. Select commands, check code and take off. Now you need to assign check code to the entire structure. Then coming to steel takeoff to the entire structure. Then you analyze. You go to select by specification all failed beams. You can see these are the failed beams because only one type of angle is provided. So we go to design tab again, select commands, select. You can see this selects the angle from the recent analysis and to pass all the beams. Now that you have assigned, you once again analyze it. Well, there is no bending in trusses because of steel. So you can see the deflection, however, and obtain its value in view. In results view value, select beam results displacement, annotate. You can see result. and the remaining others are same reactions going to beam, stresses, graphs, reports. So this is the one diagram. Coming to the other one, you can see there is no height but provided with angles. So we select file, select new project, select truss, you get some name and select meter kilonewton, select next. Well, you can see the units are kips and feet, 10 feet. So we select foot and kilopounds, select next, select hard beam, finish. Well, select front view, go to edit, so as to edit the x direction to have 60 feet. Now you just assign the 60 feet node by node. Now press escape. So first one you need is a 30 degrees angle exactly up to the center, which is 30 feet. So what you'll do is you will go to edit in snap node beam box, select skew as 30 degrees. So the grid gets aligned to 30 degrees, then you can exactly up to the center. Now press escape and go to edit, select skew as 30. So now you can see that it is aligning exactly to 30 degrees. You can now switch off the grid, then go to, however, you can switch on the grid and go to add beam, select add beam point to point. You select from here to the end point. We'll raise this a little bit, setting it to 20. So now we switch on the grid and select in this way. Now you can switch off the grid and go to geometry by selecting all entire structure. Go to geometry, intersect the members, then delete the outside beams. Now as per figure we have angles bending this side. So we will go to geometry, select add beam point to point, in this way. So you can see our truss is ready. So now go to general, select property, define, select assign profile, let it be angle, select add, close. Now assign this angle to the entire structure, then go to support, select create support, pinned and fixed butt. Assign the supports, then you go to loads. Well, as per our figure you can see there are 3 loads. One is 40 kips and other one is 10 kips. So you go to loads and definition, select load case details, select load case 1 and select nodal load, which is minus 40 kips. and minus 10 kips. So now assign 40 kips to the top node as in the figure and 10 kips to the other two nodes. Then you scale the loads. As usually, go to design, select IS800, select commands, check code and take off. You assign it to the entire structure. Then you analyze it. You go to select by specification all failed beams. You can see these are the failed beams because due to the application of single angle. However, we go to design and select in command select, so it's assigned different types of angles in order to pass. Assign it to the whole structure. Now analyze it once again. So you can see by specification all failed beams. Actually there are no failed beams because due to application of different types of angles so as to pass. Then you can go to post processing and see the deflection. You can view it in results. So you'll be doing this one, this type. Then coming to the next one, however the results are similar. Seeing the reactions, beam graphs, reports. Coming to the next one, you can see this is a pin support and this is a roller support. Here you are given at each bay the height of different members is given 10 feet, 12 feet, 14 feet. So we go to new, select new truss, let it be, and units are feet and pounds. So select feet and pounds, select next, okay, select finish. So select it to the front view, then edit it. This spacing will be 10 feet and this will be 6 on the right and 20 at the top with 1 meter 1 feet spacing. As you can see there are 6 bays which means 60 feet. So select first 6 bays, then you have 10 feet, then you have 12 feet, then you have 14 feet. Similarly draw it on the other side. Now as you have drawn the members, So you can switch off the grid, and since you see the members are downwards, so first you go to geometry, select add beam point to point, in this way the truss is created. So here is our truss as shown in the figure. Now going to general property, define assign profile, let it be angle, assign it to the whole structure, then go to supports. You can view in 3D since it is angle. Then go to support, create pinned support and fixed bar support. Assign the support to the nodes at the ends. Then go to loads and definitions. You can see in the figure there are two types of load, 20,000 pounds and 12,000 pounds, which is a nodal load. Now assign 20,000 pounds to their particular nodes using node cursor. Then scale it. As usually, go to design tab, select the specific code, it is ISC 800, and select the commands check code and take off. Then assign it to the entire structure. Now you can analyze it. You select by specification failed beams. You can see these are the failed beams because only one type of angle is used. However, you go to design tab, select commands, you select, then take off. Assign it to the entire structure. Then analyze it. So now you can see there are no failed beams. You go to post processing, view the deflection. In results you can find it, the values. So in this way we design different type of trusses. However, in the next class we will be discussing about different type of truss which usually looks like a tower. This is the end of the session. Thank you.